Hey, hi everyone. In previous video, we discussed about the in-order traversal of a tree. In this video, we will going to learn how can we do the post-order traversal. So why it is named as the post-order traversal? So at a high level, just understand we have to visit the nodes first, and we have to visit the root node, current node at last. Okay. So let's try to write the algorithm. So the base case, as we are aware about this, if root is null और current node is null मतलब this is empty tree सब tree जो भी है then return else first step if a root is not null then visit left subtree. That is the first step we have to do while doing the post order traversal. Then visit right subtree. That is a second thing we have to do. So you can see when root is not null, right? So we have to visit his children's left subtree and right subtree first of all, and at last we have to visit the root node. So that's why it is called as a post order traversal. Let's take one example. Suppose this is 1, this is 2, this is 3, this is 4, and this is 5. So we are at a root node. So as per the algorithm, we have to go to the left subtree, and here left subtree is null. We have reached the base condition. Then go back. Then as per the second step, visit the right subtree. Right subtree is null. Then go back, and we are at a root node. So visit the root node. So we have visited the 3. So the left subtree of a 2 is visited. Then go back to the right subtree, go to the left subtree of 4, come back as it base condition is reached, go to the right subtree is null, then come back, then visit the root node which is current 3 4. So right subtree of a 2 is also visited, then come back, left subtree and right subtree of a current node is visited, then visit the current which is 2. So as you can see, the left subtree of a 1 is visited. Then go to the right subtree, go to the left of 5, it is null, then come back, go to the right of 5, it is null, then come back, then visit the root node. Let's write this, which is 5. And as you can see, the left subtree and right subtree of a current node, which is 1, is visited. Then visit the root node also. That's all. So as you can see, the whole tree is traversed. We have visited the each and every node into the tree using the post order traversal. Let's try to code this. Okay.
So as we have seen on pen and paper, how can we do the post-order traversal of a tree? First of all, visit the left subtree, then visit the right subtree, and then visit the root. So let's try to code the problem, and it is pretty simple and pretty straightforward also. So let's name the function as a post order only. It will take a current node as a parameter and answer list as another parameter just to collect the visited nodes. So the base case, if a current node is a null, we can call it as a null, then return. Then visit the left subtree, which is a current node dot left and answer list. Then visit the right subtree, pretty straightforward, right, comma, answer list. And now the third step is a visit the root node. Visiting means just add the value of a root node into the list. That's all. So current node dot value. Let's call this function. Create the answer list first. So we have created the answer list. Then call the function on the root node. So pass the root node and answer list and just return the answer list. Let's run this. So at a high level, okay, just a sec. Post order. So there is a typo. Change the function name. So at high level, the time complexity of this post order traversal will be linear because for each node into the tree, we are visiting only once, and the space complexity will be also linear because if a tree is completely skewed, so the implicit stack will contain the stack which recursion uses. It can contain all the nodes of the tree if a tree is a skewed. So the both the time and space complexity will be linear. So this is pretty straightforward. Yeah, it is working. Okay, chalo, bye.